Hi guys, welcome to Colossus Mathematics class. Don't forget to subscribe, like and share this video. In today's class we are going to be talking about application of what? Differentiation. Don't forget, in our previous video we've looked into introduction to differentiation. We've also looked at some other rules we use while solving differentiation, like the chain rule, the quotient rule and the product rule. Are you seeing that now? So in this video we are going to be looking at the application of what? Differentiation. Don't forget, in my previous video I told you that the idea of differentiation is from gradient, that is m, which is equal to what? Change in y over what? Over change in x, and that's what we are writing as what? As dy dx. So if a question says find the what? The gradient, I get what I'm saying. If a question says find the gradient of a function, it means find the dy dx. I get what I'm saying now. So we used to find the what? The gradient of a curve. Are you seeing that now? So let's see what I mean. Let's look at our example 1. The question here says that find the gradient. So find the gradient. Find the what? The gradient. Sorry. Find the gradient of the following. So in this video we are going to be using it to find the gradient. I get what I'm saying now. So don't forget, I said when they tell to find gradient, it means the dy dx. So the first one says find the gradient of the curve y equals to what? X squared plus 3x minus 1 at x equals to 3. Now look at it. You want to find the gradient of this point at x equals to what? 3. Now what does this mean? This means after differentiating your y, then you are going, any answer you get, anywhere you now see x, you now put 3. Now look at it. What's our dy dx here? Our dy dx will be what? Differentiate this. This will give you what? 2x plus what? Plus 3. Yes or yes? Now at x equals to what? To 3. You do it like this. X equals to what? 3. Are you getting that? Or you just say, if you don't want to do this, you can just say at x equals to what? 3. That means anywhere you now see x in this value, you will now put 3. So this will now give us 2. Instead of writing x now, I will now write what? 3. Then plus what? 3. That will give us what? 2 times 3 is 6. 6 plus 3, 9. Do you understand the question now? So this is an example. Now let's say the question again says we should find it at, let's say again, at x equal to minus 1. I get what I'm saying. What you just do is what? Since you've gotten your dy dx, anywhere you see x, you put what? So let's say minus 1. Anywhere you see x, you just put what now? Minus 1. So our answer in this case will be what? 2 into minus 1 plus what? Plus 3. 2 times minus 1, minus 2. Minus 2 plus 3, 1. Do you understand that now? So that is how you do it. You can see this one says find the gradient of the curve. So let's see another question. No, look at the previous question I did. I don't want you to confuse it. Look at our previous question. It says find the gradient of the curve. I get what I'm saying, of the following curve. I just did only one here. I get what I'm saying. Okay, let me quickly do one more question. Let's say we have a question like y. We want to find the gradient of the curve. Gradient of the curve y equals to, let's say, x raised to power 3. No, let me not use x raised to power 3 now. Let's put a constant there. Let's say we have 5 x raised to power 3 minus 2x squared plus 7x minus 10. You want to find the gradient at x equals to what? 0. I get what I'm saying. You want to find the gradient of this curve. What will it be? You just do your what? Your dy dx. Are you seeing that? That will give us what? 15. Are you seeing 15x squared minus what? 4x plus 7. Are you seeing that now? Then what? At x equal to what? 0. At x equal to 0, that will now be what? Dy. Are you guessing that? Dy dx equal to what? 15 into what? Into 0 squared minus 4 into 0 plus 7. And that will give us our final answer as what? As 7. Now I know you may be asking a question that, oh sir, what of this our x that is in this dy dx? Are we not supposed to write dy over d into 0? No, you don't do this. I get what I'm saying. This is the derivative of the function. It does not have anything to do with what you are doing. I get what I'm saying now. So that is the answer for that. So assignment number 1, yes, I don't want to forget this. So assignment number 1, you find the gradient of the following. Find the gradient of the following curve. Number 1, y is equals to x raised to power 3 minus 5x. X raised to power 3 minus 5x plus 3. I get what I'm saying. At x equal to minus 2. Yes, find the gradient of this curve. Are you seeing that now? And then find the gradient of the curve. Find the gradient of this particular curve too. Y equals to 4x squared plus x at x equals to 1. So this is the first assignment. So find the gradient of this particular function. I get what I'm saying now. Now another thing is, another type of question that you can see under this application is, look at this question that says find the point. When the question says find the point, not the gradient. Now find the point. Look at this question. Find the point. Find the points on the curve. Find the points on the curve. Find the points on the curve y equals to x raised to power 3 plus 3x squared minus 9x plus 3. At which look at the question. At which the gradient is equal to number 1 question. I want to do it together. Number 1, at which the point is equal to what? 0. And then number 2, at which the gradient is equal to what? 15. Are you seeing that now? This is the 2 that we want to do. Now look at the question. You should find the points. That means find the value of x for which the gradient. So the first thing you need to do is to find the gradient by making it equal to the first question 0. When you make it equal to 0, then you find your value of x. So look at it. Your dy dx. This first question is saying that just do dy dx equal to 0 and find the value of x. So first, what will be your dy dx? Your dy dx will be what? 3x squared plus what? Plus 6x minus what? 9. Are you getting what I'm saying now? This is what you are going to have. Are you seeing? So what you now do is you now set dy dx. You will set dy dx to be equal to what? 0. So that means you are going to have 3x squared plus 6x minus 9 equal to what? 0. Are you seeing that now? So you are now going to find the value of x by quadratic equation. Let me reduce this by dividing through by 3. I can reduce it by dividing everything by 3, and that will now give me what? X squared. Divide this one by 3. X squared plus what? 2x minus 3 equal to 0. You can see that it has become a quadratic equation. And if you solve this quadratically, you are going by factorization method. You would have x minus 1, x plus 3. this is the value we have if you factorize this. So that means our x minus 1 equal to 0, or x plus 3 equal to what? 0. So that means x is equal to what? 1, or x is equal to what? Minus 3. So these are the points. Are you seeing that now? These are the points. These are your points. Are you getting what I'm saying? These are your points. So now, you've gotten the values of x. Are you getting what I'm saying? So that means these are their points. So what will now be the gradient at this point? You will now come back to like our previous examples. I get what I'm saying. You will now come back to you will now put the points like these points. I get what I'm saying now. So you've gotten the values at this. Your points are 1 or what? Or minus 3. So you are now saying that what is the gradient? I get what I'm saying. So the gradient at 0. So you now say that if x is equal to 1, from this place you now put it inside this equation that we have here. Anywhere you see x, you put what? You put 1. I get what I'm saying now. Anywhere you see, no, sorry, I think I am mixing it up. Now look at it. Our question says that we should find the point on the curve at which the gradient is equal to what? Minus 0. I get what I'm saying. And you've gotten when you use the gradient at 0, you got what? X equal to 1 or x equal to minus 3. Now you are now going to come back to the question. This question. You're not going to, anywhere you now see x, you now put 1. So this will be what? Y equal to, so x raised to power 3 will now become what? 1 raised to power 3 plus what? 3 into 1 raised to power what? 2 minus 9 into 1 plus what? 3. If you do that, if you solve that, you are going to have y equal to what? Minus 2. I think that means, let me write the value of that means. What that means here? That means when x is 1, our y is what? Minus 2. I think that is what that one means. When our x is 1, our y is what? Minus 2. And then the next one now, when x equal to what now? Minus 3. So this will be what? Minus 3 raised to power 3. I'm putting minus 3 back into this equation now. Then what? Plus 3 into minus 3 raised to power 2 minus what? Minus 9 into minus 3, then plus what? Plus 3. If you do that, you are going to have y equals to what? 30. That will be your answer. So this means that what? When x, look at it now. What this means now is that what? When x is what? Minus 3, our y is what? 30. So this is the answer to our question. I get what I'm saying. So these are the coordinates. I get what I'm saying. Our points is what? 1 and what? And minus 3. Our coordinates are what? When x is 1. I get what I'm saying. After getting this, you just put your answer back into the question. Alright, so do this second one as another assignment. That means instead of equating it to be 0 now, you are now equating it to be what? 15. I get what I'm saying. So let me tell you the answer you will get. Your x and your y, your x1, the values of your x will be 2 and minus 4. I get what I'm saying. You will get 2 and minus 4. And then your y value will be what? Will be 5 and 23. So make sure you solve that, get this answer, and comment yes in the comments section. All right, so thank you very much for watching. Don't forget to subscribe, like, and share this video. So in our next class, we are going to be continuing on what? On application, and here we are going to be looking at tangents. I guess I'm saying now we are going to be looking at it with tangent. Don't forget, this one that we did now is gradient on the curve. I guess I'm saying now we are going to be looking at finding equation of tangent to curves. All right, so make sure you turn on the notification button so you can get notified once I upload the videos. Once again, thank you for watching and do have a blessed day.